Kuala Lumpur, one of Asia's fastest growing cities. The problem is this: severe traffic.
Rasanya tak ada kesudahan, memang jam je.
Now there's an ambitious solution. A new transit system that will crisscross not only the city, but the entire region of Greater Kuala Lumpur. Huge machines will bore into Kuala Lumpur's treacherous bedrock to carve out almost 20 kilometers of tunnel. Every day of construction, the engineers confront the perils of mechanical failure, fire, and collapse. Get it wrong and billions of dollars of investment could go to waste, and the streets of Kuala Lumpur and its pent-up economy will stay trapped in gridlock. Kuala Lumpur is one of Asia's most vibrant cities. It's looking to compete with the region's Asian tiger economies. Its magnificent skyline testifies to its soaring ambition. But at street level, it's a different story. The city is blighted by severe congestion that threatens its future growth. Over 7 million people live and work in the Kuala Lumpur region, the Klang Valley. Every day, they head into town in 4 million cars. As an alternative, a light rail transit system was built. But over time, it has been overwhelmed, and connections are inadequate. Now there's a solution, a new mass rapid transit system that will reduce the pressure on traffic and unite far-flung parts of the city.
For any modern metropolis to be vibrant, to be competitive, to be on par with some of the leading cities in the world, you've got to have a modern public transport system.
The Klang Valley Mass Rapid Transit System, the KVMRT, is Kuala Lumpur's bid for greatness. 3 different routes comprising more than 150 kilometers of brand new lines.
It will be seamless travel around the Klang Valley, especially the areas of high concentration population.
And the first stage of the plan is the biggest test of all. This is the Sungai Buloh Kajang line. It will stretch 51 kilometers with 31 new stations. And a fifth of the new line will have to be constructed underground. To do this, 10 giant tunnel boring machines, or TBMs, will be brought to Kuala Lumpur and set to work. These mighty engines do much more than burrow through rock, astonishing though that process is. As the huge drill crunches forward, the back end constructs the tough tunnel frame with high-strength concrete. In charge of this massive operation is engineering veteran Satpal Bogal.
Most cities now, for railway mass transit systems, the tunnels are built using TBMs because of safety issues and because of ground conditions.
The underground section of the new MRT will be a perilous undertaking. For beneath Kuala Lumpur is a formidable engineering challenge. Below the city are 2 very different kinds of rock, and the TBMs will have to deal with both. The western area is known as Kenny Hill, and the eastern areas as the Kuala Lumpur limestone. Imagine the difference between a Dutch Edam and a Swiss cheese riddled with holes. Dr. Uilian Hock is the project geologist and expert on Kuala Lumpur's underground world.
I got this Dutch Edam cheese here. As you can see, this whole piece of cheese is fairly homogeneous, very tight. And Kenny Hill, when it's bedded, it looks something like this. This is like the KL limestone. All right, this is Swiss cheese. As you can see, there are a lot of cavities and voids inside the cheese. These voids can be transmitted all the way to the other side of the cheese. Things can move in from one hole to another hole, and it may come in vertically and go out laterally.
The most formidable challenge lies beneath the eastern areas of Kuala Lumpur, which rest on a huge slab of limestone. Over millions of years, torrents of acidic rainwater have eaten away the layers of rock to sculpt a hidden landscape of pinnacles, cavities, interconnected passageways, and colossal caves.
Around me here on my left is a surface cast or a limestone hill, you can say it. Now imagine when we are underground and all these are covered with soil, it is totally a different ball game. So when you tunnel through this kind of material, there are a lot of unforeseen circumstances which would be a nightmare for tunneling.
This is the worst nightmare of all. The drill head hits weak cavities and the rock caves in on the cutter head. The solution is this stuff, slurry. At the head of the drill is a high-pressure chamber that injects a liquid called bentonite slurry into the cavities before they can collapse. This ingenious system was used by the engineers who built the Smart Tunnel in Kuala Lumpur, the world's first combined storm and traffic tunnel. But builders learned some hard lessons about slurry. Ng Hawei was a rookie engineer on this project.
We have the best machines in the world in the SMART project, but we still do have some problems. We just couldn't control the slurry and it easily escapes to the surface, creating sinkholes.
What Ng and the engineering team found, to their cost, was that the slurry they injected into the limestone cavities could escape into surrounding rocks and cause havoc, bursting from the ground like a geyser or creating sinkholes at the surface that might suck in people, cars, or buildings. Today, Ng heads the tunnel team building Kuala Lumpur's MRT system. And this time, he had to find a solution to the uncontrollable slurry problem. Working with German company Herrenknecht, Ng and the team of engineers have come up with a revolutionary kind of machine.
We throw in all the ideas, we have brainstorming sessions, we consult a lot of experts, we have to do a lot of research because no machine has been designed like this before.
From these brainstorming sessions was born this mighty machine. Called the Variable Density Machine, it's the state-of-the-art tunneler. For the first time, a TBM can control the consistency of the slurry and take on whatever Kuala Lumpur's underground throws at it. Even the construction of this revolutionary machine is on an epic scale. Components are brought from all over Europe to be assembled inside the massive factory in Schwanau in Germany and other Herrenknecht plants in China.
One machine like this is fiddled together. You can say the machine is fiddled together with about 40,000 pieces one by one. The design starts screw by screw, piece by piece, and this is brought together with all our 400 engineers. They do all these works to come to this level, what you can see today.
It takes 9 months to manufacture the revolutionary TBM. Today, it's ready to be put through its paces.
We have only seen it on the drawing board so far. So this is the first time that it is all put together. Everything is running, so we can check every equipment, including the cutter heads, the hydraulics, the safety features. This is the last chance for us to make final modifications before we send it to the site and put it in the ground.
As the engineers work on the TBMs in Germany, work gets underway in Kuala Lumpur. The engineering company in charge of tunneling, MMC Gamuda KVM-RT, must complete the job in 24 months and with minimum disruption to the city above. The operation is conceived on a military scale and with military precision. The TBMs will be launched from 4 different staging zones along the planned route of the underground section of the MRT. At the western end of the tunnel, the elevated section of the MRT begins its descent underground from the surface. But at the 3 other zones, shafts must be excavated so that the different TBMs can be put to work beneath the city. Eventually, the different sections of the 9.5-kilometer tunnel must all link together. Since July 2011, work on Kuala Lumpur's new MRT starts here at the Cochrane site. It must be dug out to a depth of 30 meters before 4 TBMs can be deployed. The huge staging zones will be blasted out of the ground.
We have short time to meet our requirements, so we are working with frequent blasts, more than 2 or 3 blasts a day.
The blasting must be carried out with rigorous precision, especially in a city as dense as Kuala Lumpur.
So when you talk of blasting itself, it's dangerous you can see we've been surrounded by high-rise buildings. Now at the moment you're using about 150 to 200 kg. So that can bring a 10-story building down.
The solution is to sequence each blast, creating a pressure wave that, in theory, won't damage surrounding buildings.
These are the basic things we use. My hand now is explosive, which will be charged to the detonators over here, and it will be connected one at a time, and finally we have delays. These will segregate the blasting rather than at one go.
Engineers dig rows of holes between 3 to 6 meters deep. Then the explosive charge is inserted inside with a detonator. These are connected to a central command point. But nothing is left to chance. Giant barriers of steel plates, truck tires, and concrete prevent debris flying from the site. The charger is set. The engineers have got the right formula, and the surrounding buildings are safe. The blasting continues at the Cochrane site for 7 explosive months. Enough rock and soil to fill 50 Olympic-sized swimming pools is blown out of the ground. And finally, the site is ready to receive the first TBM. Its code name, 774. At the beginning of 2013, the first new model arrives in Kuala Lumpur. The giant machine is transported in parts to the Cochrane site on huge lorries. But that's the simple part. Now, the 160-ton monster must be lowered into the excavated shaft so that they can start chewing into bedrock.
To lift it down 30 meters down the shaft, we have to be very careful. Anything can go wrong and then we are stuck. It will push back the whole project completion by a lot.
At the site, everyone is holding their breath as the TBM begins its descent underground. Malaysia's capital, Kuala Lumpur, is being transformed into a huge building site. A new MRT system is under construction. Close to 10 kilometers will be built beneath the city, and a revolutionary new tunnel boring machine, or TBM, is brought from Germany. The first to be sent into action weighs 160 tons and has to be delicately lowered 30 meters to the tunnel entrance. The man in charge of the tunnel operation is Ng Hao Wei. He won his spurs building Kuala Lumpur's famous smart tunnel.
And we are dealing with very delicate components. We cannot afford to damage it. If the extent of damage is huge, then the impact to the project will be tremendous.
This is literally the cutting edge, the business end of the huge machine. The circular cutter head weighs 70 tons with 37 tungsten carbide cutting discs, which are stiffer than steel and denser than titanium. The entire TBM is 135 meters long, almost double the length of a 747 jet airliner. Each TBM has 10 interconnected gantries to support the operation. Only 3/4 of the shaft has so far been excavated, so the monster machine has to be assembled in sections.
We assemble up to the 6th gantry, which will give us the key components of hydraulics and electrics, so we can start to launch the machine, at the same time give sufficient space for the shaft excavation to go on.
It takes just under 3 months for the TBM to be assembled. The Prime Minister of Malaysia launches the very first variable density TBM.
It's actually a technological marvel. And it goes to show that, in partnership with a German company, Malaysians can offer a lot of our technical guidance and advice. This is something that we can be really proud of.
One day later, Ng Hao Wei and his mentor Gustav Klados arrived to check on the machine's progress. Gus, a veteran Hungarian tunneler, has worked on some of the biggest tunneling projects in the world, including the Channel Tunnel linking Britain and France, and the Smart Tunnel here in Kuala Lumpur. This tunnel warrior is the team's project manager and is thrilled to be working back in the city on the new machine.
It's uncharted territory. We are trying out something totally new. A lot of people at the beginning said, no, it won't work, but now it is excavating. You can hear the stones moving around in the pipe, so it's a fantastic noise. It's my favorite. Much better than in the office.
It's not just the machines that will need breaking in. The giant TBMs must be served by an army of workers, day and night, week after week, month after month.
I'm new here, but I try to make my best every day. Everybody starts as new. Yeah. Trust me. Yeah. Me too. I did start as a new guy. Yeah. Do you? Yes. My first job was to go and count the number of nails and bolts and nuts in the stores. Oh. And I went there and literally counted them for a week. When I finished, went to the storekeeper and he told me that, we usually use a scale.
The MRT tunneling project will need thousands of workers over the 2-year period of construction, and MMC Gamuda set up an academy to train the hundreds of workers needed to finish the tunnel on time. Veteran or newcomer, the team faces a daily avalanche of problems, and right now, the problem is pretty basic. The TBM is just not picking up speed.
8 millimeter a minute. Not very fast.
Yeah, but it's all right.
At this pace of tunneling, the project will take 4 years longer than expected and run millions of dollars over budget. But veteran engineer Gus Klados hopes that the giant machine will soon pick up speed.
In the next few months, it is just to sort of break in the machine like a horse which has never been ridden before. And I am convinced that we will make it work.
The team is under pressure to complete the tunneling works on time. In the tunnels, the TBMs never stop mining. It's a 24-hour operation. And 3 weeks since mining began, the giant machine has at last picked up speed. The TBM is like a huge underground factory, drilling, building, and spewing out waste. The heart of the entire operation is in this tiny space.
Razak, so what's happening?
Pressure sensor number 4 is broken wire.
Control cabin means the heart, the control center, the heart of the TBM where everything is controlled.
If you're building a skyscraper, visibility is not normally a problem. But underground, it's a different story. You can't see through rock. So to give the TBM's underground eyes, the machine is equipped with arrays of sophisticated sensors.
It's like when you are working in a submarine. You have to depend on the sensors, you have to depend on communications, you have to depend on eyes. Other than yourself, you can't see anything.
Inside the control cabin, engineers can work out with absolute precision the real-time position of the TBM, calculate changes of direction, and when to start lining the tunnel wall.
After a mining of about 1.4 meters, we will build the segment piece by piece and then build them up like a jigsaw puzzle.
These tunnel rings are made from 7 segments plus 1 keystone that holds everything together. The concrete wall segments can withstand extreme pressure, 30 meters underground. All day long, concrete segments arrive at the TBM. Each segment weighs 2.2 metric tons. Giant hydraulic arms swing the segments into place using the TBM's vacuum erector, which uses the power of suction to raise and position each segment. Precision is essential. If any one of these segments are wrongly positioned, the consequences would be catastrophic.
So it's very important to drum into the ring building team that they have to build it to the required tolerance of a few millimeters precision. If we are out from tolerance, the water will find its way to seep through and we'll have a great problem to seal it up.
Over time, as graduates of the Tunnel Training Academy get more experience, the process builds up momentum. In the first week, the teams managed to place just 3 rings a day. 3 months in, and the rate is 5 times higher. The campaign to excavate Kuala Lumpur's new MRT tunnels is about to enter a more intense phase. By November 2013, 4 TBMs have been successfully launched from the Cochrane site. But at another launch site near Inai Road, the engineers have run into difficulties. Here, 2 circular shafts are being excavated to 30 and 45 meters in depth. But as the shafts are blasted out of the ground, disaster strikes.
Jadi takut nanti bila dah masuk, budak-budak masuk kan, terus tenggelam.
In the heart of Kuala Lumpur, the new MRT project has hit a snag, a hole-shaped snag. Mr. Jamaluddin lives 50 meters from the launch site on Inai Road, where 2 shafts are being blown out of the rock.
Anak saya main-main di kawasan ni, di kawasan luar rumah. Dia yang terjumpa dari lubang tu. Lubang tu memang besar. Kalau dekat 2-3 orang boleh masuk dalam tu.
The hole in the garden is frightening enough, but the condition of Mr. Jamal's home is even more alarming. Floors dip and cracks ripple up walls and across ceilings. The family home is falling apart.
Jadi takut nanti bila dah masuk, budak-budak masuk kan, terus tenggelam, hilang. Takut tu jadi semua takut kami duduk luar semua, tak duduk dalam.
Terrified, Mr. Jamal calls the company in charge of the MRT project. When inspectors see the condition of his home, they make an immediate decision to move the family out. Engineers now need to explain what has gone wrong and whether other homes are at risk.
In limestone, what happened is that the solution features can be connected laterally and vertically. What happened is we drill a shaft. So this hits a connection. When there's a hole, it's like a pipe culvert. If you have a culvert connecting from the shaft to underneath Mr. Jamal's house, that forms a very easy flow passage of water and bringing the soil from underneath Jamal's house into the shaft. And that results in sinkholes.
And it's not only Mr. Jamal's house that's in danger. Water is pouring in from the walls in the deeper of the 2 Inai shafts. It's unstoppable, and the situation is a tough call for project director Satpal Bogal.
We couldn't stem it. And the decision was taken to backfill it for safety. And that decision then followed on to other changes to the program.
Abandoning one of the 2 Inai shafts is a huge setback. Now only 1 TBM can be launched from here. This means that a new strategy has to be devised. The first TBM to be brought to Malaysia, 774, that has been mining from the Cochrane site, must now make up the difference and tunnel more than twice the distance. It will put the complex machine under severe strain. It's not only flooding that makes the Inai launch site such a headache for the engineers, it's a very tight fit compared to the other launch sites. Tunnel engineer Aslan Marzuki is in charge of getting the huge TBM to the bottom of the shaft.
It's a smaller shaft. It's not a square, it's a circle. That's a safe space, but that means that our launching is going to be staggered.
The team will blast out tunnels on both sides of the shaft. Then the front section of the TBM is inserted. Next, 3 out of the 10 gantries will be lowered one by one, followed by the giant screw. The problem is that the 18-meter screw segment is wider than the width of the shaft.
Behind me, this is our biggest component that's going to be lowered down. It's the most difficult one because this length is actually bigger than the shaft itself.
The solution is simple, but risky. The screw segment of the TBM will have to be lowered into the shaft at an angle.
We have to tilt the screw conveyor at a 56 degrees angle. You have to use a chain block, a hand winch to pull the machine upwards.
It sounds simple, but that giant screw weighs a whopping 15 tons, and any deviation from that critical 36 degrees would be catastrophic. At the bottom of the shaft, the engineers face another challenge. The angle of descent has to be lowered. It's another fiddly maneuver with a lot of complicated machinery at stake.
When you lower it down, the final angle is 15 degrees. Down there, you still have to do the same exercise again, but it has to be a slow process.
After 2 hours, the screw conveyor is finally in place. It takes 3 months of hard slog to put the TBM together, but at last, it can begin burrowing into the limestone. This underworld is packed with hidden dangers. Like Swiss cheese, the rock is riddled with cavities that could wreck the multi-million-dollar boring machine.
When you're tunneling this way and you have a cave directly underneath your cutter, all right, and it's big enough that you cannot develop a face support and the thing just dips inside. And that's in that situation, then we are snookered. It will take us months to recover or to bring that TBM cutter face into operations again.
So as the huge drill edges forward at 14 meters a day, an army of engineers is busy scouting the perils that lie ahead. They drill hundreds of boreholes into the layers of rock. Once a cavity is detected, concrete is poured into the hole to shore it up. It's a process called grouting.
If we do encounter such a thing, then we'll do a lot of compaction grouting to fill up this void, like you go to a dentist to fill up your cavity, to ensure that when we are tunneling through, the TBM can go through safely.
But some cavities can be less than a meter wide. These are much harder to fill, but still pose a threat.
There's no way we can pick it up. We are unable to treat all these features along our tunnel alignment. So what we then need, we need a machine that can cater for all these little challenges.
Enter the new breed of tunnel boring machines. Behind the drill, a sealed high-pressure chamber is pumped full of liquid called bentonite slurry. Unlike previous models, the new TBMs can control the density of this thick gray liquid, changing the consistency from a thin watery liquid to a thicker honey-like substance. The thicker slurry is used to fill these hidden cavities, and its density prevents it escaping through the porous rock to the surface.
The machine, it is able to operate at different modes at the flip of a button or some switches. So by doing that, the situations we have major loss of slurry into here, we can then switch to a thicker density. All right, it's kind of a little paste that chokes up this one, and then we can mine through very easily.
The revolutionary new tunneling system soon proves to be a success. But there is a problem that all tunnel engineers fear at the back of their minds. Fire, every tunneler's nightmare. For engineers excavating Kuala Lumpur's new MRT system, the most terrifying scenario is a fire in the tunnel. A blaze can suck oxygen from the air in seconds. Workers can suffocate with terrifying speed, and the tunnel itself works like an oven, insulating the environment and ramping up temperatures to deadly levels. Tunnel workers must be ready to react at any moment, and training exercises are made as real as possible. Christopher Fenton, head of safety, health, and environment for the underground, is training the company's emergency rescue team.
Tunnels are very dangerous during construction. Fire is the last thing we want, and we need to be able to respond to it very quickly if it did happen.
He has brought in 2 fire experts from the Los Angeles Fire Department to help with the training.
We can go in here and create real live fire scenarios, and we can actually see those real life smoke conditions, whether it's good smoke that we can go in and we can find the seat of the fire and put it out, or they're so bad that we have to exit.
The men and women gear up.
Anytime when we're in here and you see your neighbor confused or disoriented, you speak up. Tell me or other instructor, and we will fix. Okay? Everybody good? Thumbs up. The calm smoke like this, lazy, sleepy. Okay, go in.
Tunnel fires can reach temperatures above 800 degrees Celsius, and in a tunnel, there's nowhere to run.
When we see upside down boiling pot of soup like angry, those gases are going to ignite.
All firefighters dread a moment they call flashover. It's when a blaze turns into an inferno. And a flashover means get out, now.
We gotta go!
The exercise proves too challenging for some.
Extremely hot, like being in a torture chamber. But it was good, very, very good experience.
It was dark, it was hot, it's very hard to describe, but you have to be able to keep a cool and calm mind. And
they know what to expect. They're better than they were before. Yeah. So we're good.
Christmas Eve 2013, and the MRT engineers have cause to celebrate. One section of the tunnel, where the MRT line dives underground at Semantan to the Museum Negara station, has been completed. It's the project's first breakthrough, and at any moment the TBM drill head will emerge from this tunnel. It's an anxious wait for tunnel manager Chin Raymond.
I told him if it doesn't come in the middle, it has to jump off a cliff somewhere.
After drilling for 6 months, the TBM punches through right on target.
Congratulations.
thank you, boss.
Well done, man. Okay. Good.
Yes, great. Finally, I pushed my machine, came in. I've been working for more than 24 hours. I can have a good rest to enjoy my Christmas.
But the machines don't get a holiday. As soon as the TBM completes its breakthrough, it is hauled into position to begin work on the tunnel that will link Museum Negara to the next station. The TBM is now burrowing beneath the historical heart of Kuala Lumpur. The Museum Negara is a repository of the nation's history and culture. Its facade is lined with precious mosaics. Further along the path of the excavation is the old railway station, an icon of the past that stood the test of time. But can it withstand the mighty TBM as they thread their way nearby?
We were stuck with having to cross under some sensitive structures, and the ground settlement would affect the existing structures.
If there's too much ground settlement, the buildings could collapse.
For the old building, actually, we had to pay much more extra care because we don't know how good is the structure, don't know how good is this building foundation. So we had to pay extra precaution on that.
A team of surveyors now equip these venerable buildings with highly sensitive sensors that monitor every vibration. As the TBM approaches, Tae Chi Yong and his team of surveyors nervously carry out hourly tests to monitor the old buildings.
The TBM is below this building directly. We get to monitor the effects and the impact of our TBM drive on the structures above, on the surface above.
It's a nail-biting 5 months of constant monitoring as the TBMs negotiate this historic region. And at last, the TBMs inch past. The iconic buildings are safe. The most powerful man in the world is coming to Kuala Lumpur. All eyes are on Malaysia. But less than 400 meters from Barack Obama's hotel, TBM 774 has come to a standstill.
I think we have problem. The school coming jam lady.
And right above the stalled TBM, ominous signs ripple across the road, less than a kilometer from the presidential residence. While the people of Kuala Lumpur get used to living and working in a massive work site, where giant boring machines gnaw away at the city's bedrock to build a new MRT, the President of the United States will be descending on Malaysia in 3 days' time. But all is not well with TBM 774. Located less than 400 meters from Obama's planned accommodation, the TBM gets a bad case of indigestion and is unable to process the waste from the cutter head. It has come to a halt. Directly above the TBM, a team is tasked with monitoring road surfaces to look for any signs of trouble. Called the Bull Gang, it is led by Michael Poon.
We have a team of people patrolling 24 hours. We have to check on the surface.
This morning I walked by, I saw some settlement. It's just a small depression. I can see the hole. It's quite deep.
At the surface, the cracks don't seem to pose much of a threat. But like icebergs, most of the danger is hidden. Down there is a void big enough to fit an electric car.
We have an unscheduled stop. They have to lower all the slurry. That means the face support is affected, and that causes a depression or a sinkhole in front of the cutter face.
An emergency response team reacts immediately. The road is closed to traffic.
Then we decide to order mortar to fill up the hole.
The hole is quickly filled with 5 cement trucks of concrete, and frantic repair works continue inside TBM 774. Across town, there is reason to celebrate. The 5th breakthrough of the project will take place today. It's a landmark moment. It means that 50% of the tunnel has been completed.
Well, every breakthrough is like a landing on a plane, right? Once you're there, you feel great because, you brought home the TBM.
The breakthrough, I thought it was very exciting. Now we finished everything. It's very, very good. I'm very content with the progress as well. The quality of the tunnel linings that we have in the precast concrete inside is one of the best one.
We work as a team. We work night and day, blood and sweat, hard time, good time. This is the prize for all the crew. This is like present.
But the celebrations are short-lived. As TBM 774 finally starts mining again, President Obama arrives in Kuala Lumpur. But to the horror of the team, another collapse occurs just meters away from the earlier sinkhole as the president is at the official state dinner. This new sinkhole is an even bigger problem than the previous one. Ground movement has broken water pipes, and the hole is filled with live power cables.
President Obama is living nearby. We definitely would not want to cut off water and power to where Mr. Obama is living, obviously. So we're trying to get this done in the quickest time possible.
Racing against time, the Bull Gang takes 5 hours to repair water pipes and fill the hole. As they work into the night, President Obama and his entourage are blissfully unaware of the battle that is being fought less than 400 meters from their hotel. TBM 774 is now approaching the zone where the underground geology changes from the karstic limestone to the Kenny Hill Formation, from Swiss cheese to Edam.
We are going through a very distinct change in ground conditions. In normal cases, you will need to use 2 different types of machines, and you will need to have another launch shaft to do this. It will take months.
But the new variable density TBMs can be retooled underground. It's a matter of changing the way waste is extracted. Instead of extracting through pipes, it needs to be removed with a system of conveyor belts right to the end of the gantries onto these so-called muck cars. The conversion takes 1 week to complete, but it's a much smoother process than the older system. But a much bigger hurdle awaits the TBM 774, an underground tangle of steel wires that could bring the TBM to a standstill. 30 meters beneath Kuala Lumpur's nightlife hotspot, Bukit Bintang, engineers excavating the underground section of the city's new MRT encounter an unexpected obstacle. Contractors of a shopping mall adjoining the street have left steel wires known as ground anchors in place, and these are bang in the path of the TBM. Put into the ground as temporary supports for the basements, they could hold up work for months.
It's very difficult to find them from the surface, and you cannot remove them from the basement anymore because the permanent walls are built, right? They are all covered.
Since the steel wires cannot be extracted, a decision is made to push on through with the TBM. But there is a continuous risk that the drill head may become entangled and damaged in the wires. It is the task of engineer Hugh Wei Hon to monitor the tunnel ahead.
So in the morning, actually, we found some ground anchors dropped underneath the conveyor belt, and we decided to stop the TBM, look for the ground anchors, cut it and remove it.
A team now has to enter the space around the cutter head at the front of the TBM. There's little space to maneuver, and temperatures are close to 40 degrees Celsius. To overcome this tangle, first, the team washes away earth from the cutter, exposing the snarl of steel wires caught in the cutter head. These must be cut away with an oxyacetylene torch. It's a laborious process. Every time they hit the ground anchors, the TBM halts as the wires are trimmed away. It takes 2 weeks to mine through this web, but it could have been worse.
If we had hit all the ground anchors that we expected, would have delayed the project by about 3 to 4 months. And we were able to go down and cut these ropes so that they weren't stopping the cutter head from turning, and we carried on.
It's the final breakthrough. After 23 months of excavation, from tomorrow, the TBM will fall silent. The honor goes to TBM 774. This was the first TBM to be launched into the limestone labyrinth under Kuala Lumpur. It has burrowed its way through almost 5 torturous kilometers of rock and soil. Now it must make the final breakthrough. It's a thrilling day for the engineers inside the giant machine.
We are about to break through. We have about 400 mm left on the cut. Hopefully we'll get a successful breakthrough.
What's happening now is we're cutting the D-wall, so that's basically the barrier between us and open air. So this is a very exciting moment for us. Any moment now, maybe within the next half an hour, we'll be out in the station.
This is actually the first TBM that we launched back in 2013. Less than 2 years, just short of 2 years, we have done 20 kilometers of tunneling. This is a great day for me and for the whole team.
Alright.
Kita rasa sebagai anak tempatan, kita rasa bangga lah.
This is the completion of our actual tunnel mining, and which is probably the highest risk on the project. Smart had over 50 sinkholes in its similar sort of length of drive. And on this project, we've had only about 3. We used a variable density machine effectively, and that has proven to be a success.
Just weeks ago, MMC Gamuda won the Technical Innovation of the Year award for the variable density TBM in the United Kingdom.
It's the biggest development in TBM technology in the last 25-30 years. So we have witnessed something new in this business. These are the most versatile machines existent in the moment. This is the future.
The last breakthrough is a landmark moment. Now the race is on to complete the stations and get the MRT running. Only then can Kuala Lumpur's clogged up traffic arteries become truly open for business.
You're basically going to live in a modern metropolis of the 21st century.
This is the new world that the people of Greater Kuala Lumpur can look forward to. A city seamlessly integrated by overground and underground MRT lines, linking together the city's heart and its far-flung suburbs, where today's gridlock is a distant memory.